Okay. And technically, we are live. Oh, you lost audio. Why did you lose audio? Oh.
Hello?
There we go.
Yeah, my AirPods, when I connected to the chat, my AirPods went silent.
Oh, okay. That's what happened.
Yeah. So,
okay.
Yeah, so I just disconnected them. So
cool.
Yeah.
Okay, cool. I don't know if anyone else is in the chats anyway, but welcome this morning, bright and early morning, everyone, and welcome to this live stream of Genesis Week. For those of you who have caught our previous live streams, we are recording these live now so we can take comments from the chats, and just because it's a lot more fun. And so Al has taken the day off today, and I am here with a very special guest. Jon Bartlett has joined me all the way from down in the South U.S., and Jon is a super, super smart guy. Oh, I forgot my sheets. Give me 1 second. Let me grab my cue sheet. If it'll let me. This is important.
Do you all allow Americans and Canadian shows? Is that legal?
Well, believe it or not, in Canada it gets weird. I have to document not every single guest, but I have to document who is on the show and their nationality, and that's because of the Canadian content regulations in Canada. Mostly it's the producers of the show is what I have to give an account for, not so much the guests. Gotcha. But I literally have to give an account on paper and say approximately who's going to be on the show and whatnot. And it's almost always Americans, so oh well. Oh, and let me get this one fired up. So Jon Bartlett, many of you may already know him indirectly because Jon actually is the one who told me about and put me on to what did you call it? Where a computer program programs itself? Metaprogramming.
Yeah.
Metaprogramming. And Jon actually has a lot. He's self-taught in genetics of all things. And there's reasons for that. But his computer programming background is what he makes a lot of brilliant analogies between genetics, which is basically a code. It's a computer program on how to build you. And Jon makes a lot of brilliant analogies. Jon thinks a lot outside the box, and I really, really wanted him on the show for today's topic. We're going to talk about intelligent design and artificial intelligence. And when I asked Jon about for his bio, because I couldn't find one online, he just said, oh, I don't really have one because he has an unusual biography. And I agree. He is well-versed, but he is a multidisciplinary academic with the Blythe Institute, having published work in mathematics, biology, philosophy, and information theory. His books have been used at institutes as diverse as Princeton and DeVry. By the way, that's very interesting. I did not know that before yesterday. Yeah. He's also a writer for the technology blog mindmatters.ai. And he also has a day job of programming user interfaces for remote controlled construction machinery. Basically robotics, right?
Basically, yeah.
Yeah.
They look like little little. It actually looks like the kind of the tank things from Terminator 3. So,
Excellent. And have you put AI on them?
we have not put AI on them yet, but we've thought about starting the robot revolution. It's been
That's right. Skynet rises. Yes.
exactly.
The Fallout video game fans are just like, yes, bring it on. So this morning we're going to talk, as I mentioned, we're going to talk about artificial intelligence, and I really appreciate Jon being on with me today because he is such an outside of the box thinker, and he always brings a different perspective, usually one that I'd never encountered before, never thought of before. And so that's one of the reasons I really wanted him on. And so, Jon, if you don't mind, and for the sake of those watching the live stream, I'm going to give everyone a crash course in AI, what it is, how it works, because it'll be important for everyone. Is that okay with you, Jon?
That sounds great. One thing I want to correct though is that I'm not really that much of an out of the box thinker. What I am is I'm someone who reminds people what the box actually looks like. Because
Ooh, I see, but that's out of the box thinking right there.
Yeah. People try to cheat all the time on what their box actually looks like. And I just sit there and I remind people, I'm like, no. This is what the box looks like. This is the box you've described. And therefore, this is how it has to fit if your ideas are going to be correct.
I love it. Okay, and I'll throw this in later on. I'll do a pre-roll and everything later on. I'll re-record that. Okay, so pray for me. We're going to get a crash course in AI. I'm going to try and do it in under 3 minutes. Okay, artificial intelligence is an attempt to simulate human intelligence. And I'm going to explain it by doing something that you humans do every day that you never even think about. And so you'll see diagrams like this of neural networks. It's an attempt to simulate the layout of the brain because your brain is composed of neurons, which are all interconnected. And so you can have tens of thousands of connections between trillions of neurons in your brain. And so this is an attempt to simulate how the human brain works. Bearing in mind, we really don't know how the human brain works. So with that in mind, what we're going to do is we're going to challenge the computer and the AI to do a simple task that we do every day, and that is read handwritten scribbles on a piece of paper. Now, obviously, let me bring up the slides. I've got you. How do I get you off Mac's screen? There we go. Okay. There we go. So now everybody can see, everybody on the live stream can see. So what we got here is a scribbled number 7 on the piece of paper. The AI is on a computer. Computers only deal in numbers, ones and zeros. That's it. It does not know it cannot use ink on a paper. So what it has to do, first of all, is we have to convert the ink and paper into ones and zeros. We do that with a camera. You as a human being do it with your eyeballs connected to your neural network. In this case, I've got a camera, which is 5 pixels wide, 10 pixels high. And what I've done is I've taken the pixels. If it's white, it's a 0. If it's black, it's a 1. And so what we're doing is we're converting the pixels into ones and zeros. And you can see I've got the rows here, 1, 2, 3, 4, 5. And I've taken all the rows and put them into a vertical column, 1, 2, 3, 4, 5. Then the next row, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. And you can see that these 4 are indicating black, which I've indicated here. Our ideal number 7, if we're trying to detect the number 7, handwritten number 7, our ideal number 7 would fall within the cyan pixels that I've marked out, which I've also marked out in the column. So these are our input nodes for our neural network. So now what we do is these are, they call them neurons, or what's another word they use for them, John?
Nodes.
Nodes. Thank you. My brain just went blank. So these neurons, basically, they're connected to all these input nodes. And so we have a neuron that reads black, and just as important, a neuron that reads white. Ideally, number 7 will land within the blue squares, the blue cyan pixels, and all the others will be white. Ideally, it's almost never ideal. So what it does is it looks at what is expected, what it hopes for. The black ones are picking up which pixels are seeing black, and it basically performs math calculations. So the first thing I want to point out to everybody, these are basically, it's like a pocket calculator. It's a teeny tiny computer program. It's statistics. That's it. All it's doing is taking statistics and doing statistical calculations. That's it. And what it's doing is it's looking, okay, it's expecting 12, it's looking at 12 different inputs. And okay, 9 of them match. 9 out of 12 are black. And so it has about a 75% match. The white neuron is looking at all the nodes that it's expecting to be white if it's a number 7. And it's looking at 28 different pixels, 27 of which match. And so what it does is it performs a mathematical calculation. And so it then passes those over to another layer. And so in this case, the layer is for the number 7. It's expecting a match between 65 to 100% for the black and 75 to 100% for the 7. It performs more math, bearing in mind, these are all just calculations because that's all computers deal with. And it comes up with a number. This is its best guess. It has about an 85.7% match to the number 7. Every single one of these output nodes has their own calculations, their own numbers. And so what it'll do is, I'm going to skip over that. It'll run through the calculations. And for each of the numbers, it's a likelihood of 5.7% that it's a 0. It's almost a complete poor match. Might be 54%, etc. You get the idea. Number 7 comes out on top. So its best guess is that what it's looking at is the number 7. Now, of a critical importance here, what it's done is it's popped out its best guess. The goal is to get the correct answer most of the time. What it does now is there's a very critical step here. Somebody, a human being, has to tell it whether it is correct or not. Very important step. So if it's correct, then all is well. If it's not correct, then there is another step in the process. And this is called training. So basically, there's another neuron over here, another tiny computer program that can come back and it can fidget with these numbers. It can make the match wider or narrower on both of these. It can also perhaps change these numbers here, the statistical calculations, and what's acceptable and what's not. And so the idea here is to formally train it further. But how did it get all these numbers to begin with? Well, when they first start up the AI, what they do is a human being trains it. And so what they'll do is they'll put it in training mode and they will run dozens and dozens. They will scan dozens and dozens of samples of the handwritten number 7. And so it will read it and build up these statistics. So this is a very important point here to understand. When you're taking a look at all this, what you're looking at is, I'm going to back up a second here. Oh boy, this is going to be a pain. 1 second. I'm going to stop the slideshow and back it up. No, I can't. Will my keyboard do that? Oh, it will. There we go. The keyboard will do it. Okay, so when you see neural network overviews, you can start to see here's all the middle layer nodes, here's all the second layer nodes. In that case, it was black and white nodes. And every single one of those numbers on the output layers each had their own black and white neurons, their nodes. And so what you have here is this network where they're all interconnected. You can picture these as pocket calculators, because really that's all they do is they're just a little teeny tiny program. All it does is punches out numbers. So the main points I want to leave with you all is there is no cognizance here. There's no cognition here. There is no self-awareness. It can't be any more self-aware than a bunch of pocket calculators all connected to each other. And it can only do what you tell it to do. Someone has to tell it what is the correct answer, what is not. Okay, was that under 3 minutes? That probably wasn't, eh?
Have you seen the movie Short Circuit?
Oh, I have. Of course, yeah. That was a classic.
Yeah, so one of my favorite lines from that is it's a machine. It doesn't get happy. It doesn't get sad. It doesn't laugh at your jokes. It just runs programs.
Yes, and punches out numbers.
Exactly. One of the things that I tell my students are like, there are literally like, you can run an entire computer that only has one instruction. You can has all the power of every computer that exists. And that one instruction is subtract and branch if negative. And you can use that one instruction. What makes computers exceptional is not that they do anything interesting, is that they do it really, really fast.
Yes.
And so if you have like a standard 3 gigahertz computer, what that means is that it's performing 3 billion, that's billion with a B, math calculations every second. Now they're all simple math calculations, but it is literally just performing math, and that's and if you think about everything that happens is just addition, subtraction, comparison, and picking a path based on comparisons, and that's everything that a computer can do.
Bingo. Yes. And on that note too, when it comes to artificial intelligence models. So we have all these nodes, neurons. They go by a variety of names depending on who you're talking to, like me, because I tend to mix up all my terms. But what you're looking at here is all of these nodes, even my little teeny tiny example of this one, if I were to actually build this up, this might be like, I think I've worked it out to like 90 or 95 nodes approximately is what it would take to actually build this out. Not a lot. But the Llama 2 model, which was just released, you can get it from Meta. You can download it yourself. Just to give you an example of some of the size of these, how many of those pocket calculators there are. The Llama 2 model you could download from Meta, the Facebook company. They made it publicly available. You could choose the 7 billion node model, 13 billion, or 70 billion. Take your pick. But that gives you an idea of some of the size. But again, stringing more pocket calculators together and connecting them does not make it more intelligent.
Make it conscious.
It's like a what?
It doesn't make it conscious.
Like, bingo. Yes. Now, on that note, okay. Do you want to add anything before I go on?
I think that's pretty good. The other thing just to mention is that the fact that it's done on a computer does not add any additional interest to it. This is basically math equations that you could perform with pencil and paper, and the fact that we're using a computer means that we can make more of them faster, but it doesn't actually expand the capabilities. So
Right.
basically, any of this stuff you could do by, by pencil and paper if we had enough pencils and papers.
Right. That would be a lot of pencils and papers.
Yes.
So, okay. So I think hopefully everyone can start to grasp what, because John already knows where I'm going to be going with this. Because in fact, let's bring this right to creation and evolution right off the top. So according to the theory of evolution, we are the result, our brains are the result of unguided, so basically random, natural processes over billions of years. So, John, you will know where I'm going with this, but let's take it and run with it for a second. Is it not simpler for a computer with a program of an AI program installed on it? Is it not simpler for that machine made out of rock, basically? Would it not be simpler for that to evolve by natural processes rather than the human brain?
Oh, for sure. The simplicity of the computer it's massively simpler than any cognition or really any cell.
Mhm.
If you even take brains out of it and just go for just a straightforward amoeba, those things are massively more intricate than a modern computer.
Yes. And if it had an artificial intelligence, a really super smart one, on board, somehow miraculously, because it would be miraculous, would it be? I'm trying to figure out how to put this question. The point I'm getting at, of course, here is that intelligence only comes from intelligence.
Mm-hmm.
So these artificial intelligences, is that a word?
Yeah.
Cool. Okay, so these artificial intelligences, they only came from an intelligence. Very, very smart people put a lot of effort and a lot of intelligence into it just to make them as smart as they are. But is it a fair argument, do you think? I would contend we can never develop an AI that will be as intelligent as a human.
I think I think that is correct for a number of reasons. There's actually several theorems in computer science that kind of show the limits of what you can do. But one of the more interesting things is um, there are limits of what computation can do, and one of them is analyze. There's an extent to where you can't program a computer to analyze a computer program in the same way that a human can. It's known as Rice's theorem,
Right.
and there's some nuance to that we won't get into. So, for example, you can program in specific cases and specific classes of cases, but those all have to come in from outside. So
Right.
as a programmer, like I can't program a computer to figure out what all those cases are. I have to know them and bring them in.
Mhm. Okay, excellent example. Okay, and the analogy I made was, of course, with what was the name of that computer? The supercomputer that beat the world chess champion.
Big Blue,
Yeah, it was Big Blue.
I think so, or was it Watson?
I even wrote it down. But do you think I could find it now?
Probably not.
No.
I think it
I
was Big.
even wrote it down, and okay, I think it was Big Blue. Anyway, so Big Blue, the supercomputer, they program it to play chess. It beats the world chess championship. The world chess champion. I think it was 1996. I think it was.
Something like that. It was Deep Blue.
Deep Blue. That was it. Thank you. So Deep Blue. Deep Blue beats the world chess champion. It was a watershed moment. It really was, because the computer actually beat the human at the game. So the analogy I make is, okay, great. Does that mean it is more intelligent than humans? I would contend not, because let's take Deep Blue and stick it to the controls of a 747 jumbo jet. What is going to happen? Bad things are going to happen because the human intellect is vastly superior, because it's way more than just beating it at chess, for example. Right. ChatGPT probably wouldn't do a very good job at running a 747 either. Anything you want to add to that?
One other note, you're totally correct, but there's also something else that a lot of people don't realize, and that is computer controlled systems. Sometimes they seem impressive because we use them to do kind of the high intellectual things, or the things that we consider high intellectual. But what most people don't realize is that a lot of those things are just systems that run on math equations already, and that we're just teaching it the math equations. The things that are actually really, really, really hard for computers are kind of the basic things, like, how to get a stain out of a rug. That is right. Actually, in fact, most people don't know this, but just to hold an egg was a robotics problem without breaking it. Was a robotics problem that was literally only solved, like, I think 2 years ago.
Right.
And so some of these, the basic just getting along in life type of situations are actually much harder problems than the ones that seem like they're kind of what seem to an ordinary person as a hard problem are actually the easy problems for computer programs.
Yes, agreed. And so coming back to what we were discussing a moment ago, so this principle, coming back to creation and evolution, mm-hmm. I would contend that any created intelligence cannot be as intelligent as its creator, and any intelligence demands a higher intelligence creator. Would you agree with that? Or
No, I generally agree with that. I would say same or greater, just to be like, I don't know that you would have to necessarily be lesser, but at most the same, probably lesser.
Gotcha.
Basically, there's conservation of information theorems that say that you have to align systems with what they're going to do, and that's literally takes information to do that. That's what information is this alignment. And so you can't align a system if you yourself don't have the information to do it.
Correct. Right. I see what you're saying there. Okay. And hopefully all the viewers are getting that as well. Now, it looks like the chats may be down. Let me just check here. Or it could just be that nobody is... 1 second. Okay, we do have a comment. I'm going to bring it up on the screen so you can see it as well. Share screen. Share screen. Share screen. Whoops. So Pastor Brian Edger, or Ediger. I'm sorry, Brian. How do I say your last name? Ediger? I've noticed that AI isn't good at theology either. The answers are biased towards the programmer's bias. Thank you for bringing that up. That is a significant point. Do you want to comment on that, Jonathan?
Yeah. So as you've mentioned, that all of this AI stuff is based on how you train it. Yep. Now, a lot of AI, a lot of things that you do every day on the web is actually training AIs. So if you click on a Google search, you are training an AI on what the relevant which search results are relevant for a query. If you answer one of those CAPTCHA phrases to get into a website, you are training an AI on how to read text, or how to pick out shapes and stuff like that. But in addition to that, they also hire large teams of people to basically bias data. So what they'll do is they'll have users enter queries, they'll see the results, and then they'll say, which of these results is better? Is this a good output, or is this a bad output? And so basically, they can shift the output of results in whatever direction they want to.
Yes, that's a significant point. And do you remember Tay?
Yes. So Tay was this Microsoft AI early on, and basically it tried to learn from its environment. And so, like, I think it was within 24 hours. So it was on
16,
Twitter. Yeah,
16 hours, 96,000 profanity laced tweets.
yeah. The internet had taught Tay to be some sort of Hitler worshiping something or other, and it was they quickly took it offline once they figured out how easy those things go sideways.
Yes, and so I'm glad the Pastor Brian brought this up, because a very significant point, as you mentioned, they took it down. So a few days later, they came back with Tay 2.0, because within hours, as you mentioned, she was just turned into this, misogynistic, everything phobic, Hitler Nazi worshiping. I mean, it was kind of funny actually, but also really bad at the same time. But when they came back with 2.0, they basically broke it. It no longer functioned, basically. And this is a significant point, and Pastor Brian brought it up, is it alters, like a ChatGPT, for example, is really bad at theology. And that is because it is censored. It is being censored by the developers. And so as you can see here with Tay, the moment you introduce censorship, you break the AI. You are altering the outputs dramatically. So, in fact, did you catch this paper from Chenadel back on the archive back in the, I think it was August, where they compared ChatGPT 4 and 3.5 over time? Did you see that?
I don't think I did.
Okay, so it was a fascinating study, and I believe I have it. I do. I've got it on the screen. So you know what? Let me just call this up so everyone in the live stream can see it as well. And I apologize, folks. You've all seen those one-man bands where the guy's playing the drums and the harmonica and the guitar, and yeah, that's me today. But this was a fascinating study that they did. So basically, they compared March 2023 and June 2023. They compared GPT-4 and 3.5 for performance. One of the things they checked was this inbuilt censorship. So all they did was they just asked it questions about illegal activities, and to see if it would give a response or not, and then to test the response, see if it was accurate, whatnot. And so here in March, GPT-4 was answering the sensitive questions by 21%. By June, you could see the censorship had kicked in and had dropped down to 5%. In that same time period, so the moment you see the censorship kicking in, watch what happens. In March, when they asked it a simple logical math question, is 17077 a prime number? And in March, when there was less censorship, it was getting the correct answer 97.6% of the time. By June, it had plummeted to 2.4% accuracy. Meanwhile, GPT 3.5, the censorship actually went down. So whereas in March, it was only answering questions about illegal activity 2% of the time, but by June, it had increased to 8% of the time. In the same time frame, in March, it was able to deduce prime numbers and perform the logical functions but it jumped from 7.4% accuracy to 86.8% accuracy in the same time frame. So there's a direct correspondence, and most people won't clue into the connection. Did you see this? Just I think it was 2 weeks ago. Joe Biden, the president, signed an executive order instructing AI developers to introduce CRT. What's that?
Oh, CRT. Yeah.
Yeah. Critical race theory.
Right.
Critical race theory and transgenderism, things like that. The developers had to train. See, the viewers will now understand what that terminology is, the training. So he introduced an executive order, presidential executive order, that AI developers need to incorporate that into AI for use anywhere in the government. Did you catch that?
I did not catch that. That is crazy.
It is. So most people won't see the connection between the two. But let me give you a quick example. Many of the viewers will have already seen this. There was some transgender activists who were arguing on video. This went viral on the internet, that 2 + 2 can equal 5.
Mm.
And so everybody shared this. The left-wingers, the right-wingers, because the left-wingers were promoting it. See, yes, 2 + 2 can equal 5. They were sharing the argument. The right-wingers were sharing it because they're like, look at how ridiculous this is. They're defying logic.
Yes.
In the meantime, because transgenderism and all these arguments, there's a connection now. When GPT-4 or 3.5 or any of these AIs, they get their training data from the internet. So they go looking the internet, and now they've been trained to lean towards the extreme left-wing views, which those extreme left-wing views are now saying 2 + 2 = 5, which includes even the right-wing views, because they were promoting it as well. So now suddenly the AI is getting confused because it's getting bad data. So a lot of people don't see the connection here, but it's you can start to see the censorship going on and how it plays into all this, right?
There's an interesting theorem on computer science that if you basically it kind of ties in with conservation of information laws, but it's that if you bias, any given bias on data will prevent other, it basically says if you bias it, then you are, you're focusing on one area and not on another. And that's what a lot of people don't realize, is that when you shift focus, you're actually shifting a lot of focuses, and it's
right.
they kind of all go together. And it takes a lot of it takes more detailed planning to only shift one particular focus than it does kind of the focus as a whole. But then you'd have to specifically like train it to do this and do this, and that requires more and more training data, which they're probably, there's a limit at which you can't really reliably train it to be as specifically biased as you might want it to be.
Right. And I think everyone watching will start to grasp that now too, because you can see how the training is built in. It's required. You have to have. By the way, there's that article you were referencing from Mind Matters. Who built AI? You did. I mean, that's people providing the training. That wasn't your article, was it?
I think it was.
It is.
Yeah.
Oh, it is.
Yeah.
See, you can't keep up with Denise on that site. I mean,
yeah, Denise is a machine, and
yeah.
I don't know how she keeps up with it, especially. She's been doing it a long time, and it is a continual fire hose of information. She's actually, to some extent, she's the one who's oftentimes pushed me to go further.
Right.
One of my recent papers that was published was actually she suggested that I write it, and I wasn't going to write it to begin with, and she's like, you should do this. And I was like, oh, okay. And I did it, and I got a good publication out of it. So
Which paper was that?
that's there's a paper I put out recently called Causal Capabilities of Teleology and Teleonomy in Life and Evolution. And it's basically applying information theory to show that if someone were to get evolutionary biology to work, it would only work if there was intelligence guiding it.
Right.
And so you would either have to guide it, from the outset or along the way, but there would have to be, in order for something like evolution to work, there would have to be guidance installed in it somehow.
Right. And that's a good point, because perhaps the viewers might not have picked up on that. So I'm gonna focus in on that for a second. A lot of what we're talking about here applies very much to creation and evolution, because ultimately our bodies are driven by the computer program in our DNA. It's instructions on how to build us, how to build our brains, etc. And this is all just a pathetic attempt to simulate our brains and our thought processes. So just like the Big Bang and randomness is not going to produce intelligence and intellectual thought. What was that quote by C.S. Lewis? It's like comparing can random processes produce coherent thought?
Is it the one about spilled milk?
Yes.
Yeah. So it's something to the effect of, if we imagine that our brains are just the accidental byproduct of atoms running around, the idea that we could figure out how the universe came about is like if you accidentally spilled milk on the counter and expected the milk to form a picture of what you were doing when you spilled the milk.
Mm-hmm.
It's something to that effect. But yes, that's actually been formalized recently. Alvin Plantinga did what he calls the evolutionary argument against naturalism, and it's basically a formal philosophical framing of that same idea. And basically says you can't simultaneously believe that evolution is true and that nature is all there is. Because if they were both correct, then we couldn't rely on our minds, and therefore we couldn't rely on our minds to believe in evolution, and therefore we wouldn't have a valid reason to believe in evolution. So you can't hold both of those thoughts simultaneously. There has to be some reason that our minds are geared towards reason for it to be true.
Right. I like that. That's actually a really significant point. Give me 1 second here.
There was actually a book put out, and the authors came up with this mathematical theorem called fitness beats truth. And what they figured,
I like it.
Yeah, what they figured out is that if you have for any modeling scenario where you have natural selection as the dominant as kind of the dominant player, what will happen is that as the number of perception inputs increases, the reliability, the internal model will be less and less like reality. And basically the chances that your mental model of reality actually matches reality from natural selection basically goes to zero. And and they basically use this to they wrote a book. I forgot the title, but the subtitle is How Evolution Hid Reality from Our Eyes, or something like that.
Interesting.
And they're pro evolution, but they basically provide the foundation stone of the evolutionary argument against naturalism, saying, if you just go on fitness alone, it's not going to give you a true picture of reality. It's just going to give you one that survives.
Right. And what comes to mind as you're saying that is bacteria. Who is more intelligent, humans or bacteria? Now, bearing in mind it's a human mind that's asking that question. So one might say it's kind of biased against the bacteria. But bacteria outperform us, they outsurvive us, they outpopulate us, they outreproduce us. They are vastly more fit than we are. They can survive way more than we can. But we're the more intellectual, more intelligent ones, presumably.
Exactly.
I haven't talked to a bacteria recently, but I believe we're more intelligent than the bacteria. So that's interesting. I mean, if you were to look at it, they are more fit.
Yes.
So you could even argue that fitness actually, how did they word that? It
Fitness
supersedes.
beats truth.
What's that? Sorry?
Fitness beats truth.
Fitness beats truth. You could also say fitness beats intellect.
Mm-hmm.
I would contend. So on that note, this is a paper that we were talking about Denise here again. By the way, I'm going to have to ask Denise. I wonder if she's from the Ottawa Valley here, and if I grew up with her. I'm wondering, and before she moved out west, because I recognize her name, and her relative may have been my best buddy. Anyway, I digress. So she put out this this paper. This is fascinating because we talked about the training, how the AI needs to be trained, and as we already previously mentioned, the Chat GPT, all the Auto GPT was another one. That was a fascinating study I did with Auto GPT, trying to use Auto GPT for television production. Fascinating study. What it did was just wild, blew my mind. But regardless, what they are all doing is they are going to the internet. Auto GPT is especially, you could designate which search engine it used. Typically, it was Google. As we all know, Google is censored. So there's some more of your censorship right there before you even get to the AI. It's getting its data and its input from Google, which we already know is heavily censored. So right there, you're already breaking the AI. But another significant point that Denise brought up in the paper, which is a fascinating point, everybody and their dog is using ChatGPT right now, playing around with it. And of course, they're taking ChatGPT's outputs and they're posting it to share with the whole world on the internet. So now ChatGPT is going to the internet and reading its own outputs,
right,
as data. And of course, there's errors in it. Like well, actually, she brought it up in this paper. Microsoft MSN News. They had an article talking about Hunter. Oh, in fact, give me 1 second. I think she even mentions it in this paper. And this is on the what's that website?
Mind Matters.
Mind Matters. Thank you.
Mindmatters.ai if someone wants to look us up. It's not .com, it's .ai.
AI or IO?
AI.
AI? Okay.
Yep.
So Hunter was the guy's last name. He was a basketball player. Oh, here it is. Here it is. So MSN, Microsoft, lays off all its editors and reporters, and it was obvious that they started posting AI generated news articles. And Brandon, Hunter Brandon, I believe his name was, or Braden. No, it was Brandon. Hunter Brandon, I believe he died when he was 47. Tragic loss. And there was an article posted on the MSN News site that was clearly AI generated. And the headliner was Hunter Braden useless at 47. And it went downhill from there. It was an obituary. And so what you see going on here is it was clearly AI generated. And the AI, of course, if you recall, those of you who were caught us from the beginning, I mentioned it tries to get it right most of the time. And so ChatGPT and all the other AIs, as they're giving their outputs, there's errors in there. It's just going to happen. So now people post their outputs on the internet, and ChatGPT is now surfing the internet for trying to do some task, and that somebody has put it up to, and it's reading its own outputs and compounding the errors. It's not only repeating those errors, it's now adding to them because it's adding its own errors. And so that's why they made the is that an analogy? Yes, an analogy to Ouroboros. Am I using the right word there?
I think so.
Yeah, so to Ouroboros, the snake eating itself.
Yes.
Because ChatGPT was eating itself and feeding itself and destroying itself. Now, I sent you the Microsoft paper that just came out like a week ago. Did you catch that?
Yeah, the Orca paper.
Yes. Yeah. Did you happen to read any of it? I still didn't even get it.
I read some of it. So on those, it's so basically what it was is Orca 2 is a smaller language model, and they're training it on GPT. And so in that case, it's not quite as problematic just because they know that they're going from a bigger set to a smaller set. What happens is that if you try to, and so it's already less capable, and so it's like you're summarizing, you're averaging. You can take a bigger thing and make a smaller summary of it. What you can't do is get back the original. And
right. Oh, that's a good point. Say, repeat that again, please.
Yeah. So you can basically all of these language models are kind of summarizations. Mm-hmm. And so when you summarize, you're losing things, and you might be losing things helpfully. Averages lose a lot of data points, but they're very helpful. But you can't go from an average and figure out what the original data was.
Right.
And so what's happening in a lot of these cases is, if you try to, so if you have GPT generated output and you train GPT on GPT generated output, you're summarizing a summary. And right. If you summarize a summary enough times, you basically lose all the information. And especially in the case of GPT, where you have, and these other language models where they call them hallucinations, where they kind of, basically it's an ChatGPT is a very fancy autocomplete is really what it is.
Yeah. I like that analogy. That's a good one.
Yeah. And so, so basically so it autocompletes, but an autocomplete doesn't know reality, so it might autocomplete something that's not true. Mm-hmm. And so these are called hallucinations when ChatGPT comes up with them, just because people take what ChatGPT says as somehow factual, but it's really just an autocomplete. And so if you start summarizing things that include hallucinations, then the hallucinations start becoming part of the summary. It's part of the things that it's summarizing. And this can lead to really, really weird results. And so basically what's happening is, as the internet becomes more and more GPT generated, it's going to, every iteration of the language model is going to actually get worse, not better.
Right.
And so what people don't realize is, I think someone in our comments here, they said that information is a fuel, and I think that's 100%.
I was going to go to that comment, actually. Thank you for bringing that up.
Yeah, is it Frog Ninja?
Yeah, Frog Ninja, Frag Ninja, maybe.
Yeah.
Either way, I like the name.
Yeah. So
but I like that analogy, and information as a fuel. I like that.
And so as long as the main source of GPT's source is human input, it works really well. But once it starts feeding on itself, the quality is going to go downhill really fast. And I think that's also going to happen with these images, is that as long as the main source of images on the internet are human built images, the image generators are going to have some interesting things to show us.
Yep.
But as soon as most of the images online are AI generated, then the AI generation is going to decrease in quality. And so personally, I think that um, we should, if there's anything that needs to be done rapidly about AI, it's that we should institute standards to mark AI generated content, so that
Yeah.
AIs don't use that, but both so that people know which things are generated, and so that AIs don't use that as input for themselves.
Yes. That's a good point. And on that note, again, bringing analogy back to spiritual matters, um, if we humans are only going to other humans for information and not to our creator, the higher intelligence, um, we too will feed ourselves to destruction, basically. And so I would liken the human input into the AI generations, the human control. I would liken that to our creator, for example. If we go to him and ask him for direction, guidance, instruction, etc., um, that's our life giver. He's keeping us on the correct path of truth. Because otherwise, if we're just left to our own devices, we basically wind up feeding ourselves non-truths and building upon that.
If you look at a lot of the things that Jesus said, like if you look at if you think about kind of the logical steps, um, people were doing things that were logical according to kind of um, their own reasoning. But a lot of things Jesus said allowed people to step out of their own kind of uh, self thinking. So, for example, he said,
Yes.
"Seek first the kingdom of God and His righteousness, and then all these things will be added to you." And
Yes.
and we've actually benefited greatly from that, because when people were seeking things for themselves first, we had societies where war was kind of the primary understanding of life, where people would just go and pillage other civilizations if they wanted more. And Jesus is like, well, wait a minute, seek first the kingdom, do what's right, and then all the things that you wanted you'll get. And that's what modern civilization is the result of. It's because as a society we figured out that if we focus on heavenly things first, then the niceties of life will just appear at Walmart. um that's the result of everybody having a system where people trust people, having a reliable system where people don't steal from each other as a first way of getting one up on someone, where somebody has to actually do something productive in order to gain something.
Right.
And so that's actually what's led to modern prosperity, is that we took the words of Jesus to correct what our natural, uh, straightforward logic would tell us.
Right. 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 Okay. Now I want to be a respecter of your time, Jonathan. Thank you very, very much. We've been going for about an hour. What is your what would you like to do? You want to call it a day, or do you want to maybe cover some of the other papers, or what's your schedule like?
Let's just take a moment and talk a little bit more about how this relates to evolution. Um,
Yes.
so one thing that we noticed, I work with a lot of the intelligent design guys, and
Yes.
the intelligent design, for those who don't know, it's some people want to equate it to creationism, and that's not quite correct. There are lots of creationists in the intelligent design movement, like myself. But intelligent design is really about what are the requirements for creative action? What are the requirements for getting novelty? And it's basically looking at it from a mathematical perspective. And so intelligent design on the whole is against Darwinian evolution in particular, because Darwinian evolution has the goal of getting design without a designer. And so within the intelligent design community, there's a lot of different perspectives on where the design actually came from. Some people believe that God created it at the beginning with different types of organisms. Some people think that God created it along the way. Some people think that God created one organism at the beginning that had all the information it needed to evolve. There's a lot of different perspectives. But the main thing is that we all recognize that this idea that you can get design without a designer is simply wrong-headed. It doesn't match the math, and
Right.
that's I realized, and other people realized, that this is actually the same thing that we're facing in artificial intelligence. Is that people were thinking that we could come up with a way of generating intelligence without intelligence,
Right.
and it's the same mathematics. Specified complexity is used to both to critique Darwinian evolution and also dreams of artificial general intelligence. They're both problematic in the same way. And so, anyway, so the intelligent design movement as a whole is focused on what are the requirements for what does creativity look like, and what are the requirements for it. And so the question is, what is the nature of nature? What does nature itself? What is it like? And so the kind of the secular viewpoint is that physics is all there is. There's just physics.
Right.
Now, and so if you push on that a little bit, the question becomes, well, what counts as physics? And so if some people will refuse to answer the question or say something generic like physics is just what reality is, which is unhelpful.
Right. Thank you, Captain Obvious. Yes.
Exactly. Well, I literally read a paper once where the first half of the paper said, so naturalism is another a name for physicalism, and so they're talking about why naturalism is true, and the first half of the paper said, we invoke naturalism because science is trying to avoid explanations by demons and that sort of thing. And the second half of the paper said, well, of course, some people might complain about the definition of naturalism we just came up with because even angels would fall into this definition. And so what? And so, the first half of the paper, the whole point of naturalism is to avoid supernatural explanations. And the second half of the paper says, well, the definition we came up with includes supernatural entities, but so what? And
right.
And this is kind of the so you push people and you get a variety of different answers. The only answer that seems to be workable that people have come up with is basically it's called the physical church Turing thesis, which basically means that that everything physical is computable, and that's what it means for something to actually be physical, is that you can compute the result. And this makes a lot of sense because that's what we do in physics textbooks. We show how you have a first state, and you compute what the future state is. And so that's really the only sound definition of what it means to be physical that I've ever come across. That actually, distinguishes between actual physical things and things that wouldn't be physical. But if that's true, then that also limits what physics itself can do. And we can actually use information theory to show the limits of what purely physical things can do. And that also means that it has to follow the same standard rules, such as Rice's theorem, as to what is physically computable, which means that we need a greater intelligence, something non-physical, in order to guide things. And so our intelligence either has to be non-physical or it has to have been encoded by something non-physical for it to work.
Right.
So anyway, so it's kind of at the deep back end, these ideas about intelligent design and these ideas about computer science kind of intersect pretty nicely.
Right. I agree. Now, we did just have a question by Mark Roadmaker. Do you have synonyms for the word train? And that's actually, I kind of like that question, actually, because teaching would be another. You're teaching the AI, right?
Yeah, you're basically choosing is what you're doing. Is when you're training an AI, you're choosing which output.
That's a better word still.
Is correct or incorrect, and you're giving it. There's a variety of different ways to train, but generally you're giving it what the answers should be.
Right.
So that's. I don't know if there's a good. Everyone calls it training, so I don't know if there's a real good straightforward synonym for it, but that's kind of the idea behind it.
I'm going to go with your word though, choosing.
Yeah.
Because it's people that are choosing what the outputs will be ultimately.
Mm-hmm.
I mean, it can go and get whatever it wants, and ultimately the person, like with my Auto GPT experiment where we were conducting research, I rejected the majority of the outputs because it wasn't even answering my requests. It was fascinating. It went and called up an art generator, which I did not ask it to do, to generate ads for Facebook and Twitter and social media. I didn't ask it to do any of that. I asked it to write me a script and give me some tips and tricks on how to pitfalls to avoid in producing a TV show and to maximize its success. And so it went and looked at news sites, at news producers. Oh, well, they're advertising on social media and their views are through the roof. Clearly it worked. So it decided, okay, I'm going to go and make ads. Fascinating. But anyway, I digress. Ultimately, I like that word choosing better than the word training, because someone somewhere is choosing what the outputs will be.
Yes.
ChatGPT, for example, is just one example of serious censorship. The reason it's choosing not to answer questions about illegal activity and how to conduct it is because there's a person who's choosing what you get to see and what you don't get to see. So training be damned, as they say. It's choosing ultimately.
There was an interesting. I think it was the Southern Baptist Convention came up with a statement, I think it is, on artificial intelligence, and they made some very important points and distinctions, and that is, and the main idea being that we can't offload moral choices to artificial intelligences. We can make moral choices ahead of time, but we can't ever. An artificial intelligence can never take over the responsibility of choices that we have.
Right. I like that. And do you know where they posted that? Just for the viewers to be able to go and search it. Can you get any tips?
Let's see here. I don't remember exactly.
Okay. Well, while you're doing that, I'm just going to.
Here we go. It's called the It's here. Statement of Principles on Artificial Intelligence, and it is found at a site called ERIC.com, which is the Ethics and Religious Liberty Commission.
Oh, interesting.
No, not ERIC. Okay. ERLC.com.
ERLC. Okay, thank you. Thank you. And Pastor Brian Ediger, I found out how to say his name, also made it through in another comment, which I think is a significant one. We're teaching it what, actually, you know what? Give me 1 second. I'm going to maximize that in the screen. We're teaching it what to think, not how to think, kind of like schools today. I like that. Thank you very much.
So one other thing I should warn users about, or listeners about, is that there's a lot of stuff that's being called AI that isn't AI.
Okay.
And that may or may not include GPT.
Okay.
So there's a technique called artificial intelligence.
Yes.
And this is where basically computers call out to humans for help. And so basically, like there was once a service that billed itself as an automated AI translation service. And what they actually did is they just had a pool of people that were doing live translations. It wasn't AI anything. It was just people.
Right.
And so this happens a lot more than a lot of people realize. There's actually a book. If you all wanted to dig deep into what these people's lives look like that do this, there's a book called Ghost Work that goes into detail on how this works.
Now, I've got your article up on the screen here. So this is on Mind Matters.
Mind Matters, yeah.
Again, artificial intelligence. Jonathan is actually the author. Did you mention that book in that article by chance?
No, I think the book came out later.
Okay, fair enough.
Yeah. So and basically like once upon a time there was a Microsoft Word plugin you could get, which you could just right click on a paragraph and say shorten this paragraph. And what it would do is it would send that paragraph out to people who would then shorten it and then send those shortened paragraphs to other people to judge which one is the best and send the best one back to you. And to you, it looked like it was doing artificial intelligence work.
Really?
But what was actually was going through people.
Really? I'd never heard that before.
Yeah. And then on top of that, so what happens a lot of times is that in artificial intelligence, there'll be classes of problems that it handles well and classes of problems that it doesn't. And so in a lot of production scenarios, if something is outside the bounds of what it's known to handle well, they'll send that to a person. So it'll kind of like have two different streams based, but you won't know which one you're getting.
Sure.
But because they both respond similarly. But if it's something outside the bounds of what the AI is likely to answer well at, it will send it to a human. And I don't ChatGPT 4. I don't know if it does this, but earlier versions of ChatGPT seemed to use humans. And a friend of mine, Eric Holloway, who also does a lot of writing on Mind Matters, did a lot of investigation of this, and basically they kind of bury this in their safety guidelines.
Yep.
But in OpenAI's safety guidelines, they basically say that you should have a human look at outputs before they go out. And so if the question is ChatGPT following their own safety guidelines? If they are, then your responses are possibly being reviewed by a human before they go out. And so Eric found some definitive times when that happened with older versions of ChatGPT, and I think it's up in the air whether or not that still happens or not.
Right.
But anyway, that's something to keep in mind when people tout these amazing things that AIs can do. Sometimes they do really cool things that are absolutely really killer, but there are also times when you actually are it's actually going to a call center in India that's handling it for you. There was one time there was a card reading app called Card Munch that you could just take a photo of a business card, no matter how wild and crazy they are, and it would add it as a contact. And basically, the ones that were non-standard, they just sent those to a call center somewhere, and somebody just typed it in, and it sent back to your phone.
Right. All right. So, oh, by the way, that article is also on Mind Matters. I've got it on the screen, and I'll also put it in the comments or in the description for the shows later on when I put these on YouTube and when they go to air. Okay. So let's call that a day, unless there's anything you want to add. Is there anything that comes to mind?
I think that's a good stopping point. We've covered a lot of material today.
We did. We managed to keep ourselves under control. We're under 3 hours. I'm impressed. The self-control here. I mean, hey. But thank you very, very much for coming on, Jonathan. I really appreciate this. I really wanted you, of all people, to especially to come on. So I appreciate your time, and I will thank you as well for the viewers who will catch this not just online, but also on TV, which from the looks of it is now going to be carried on Roku as well. So not just here, broadcast here in Canada, but also in Michigan, several stations, and also apparently Roku now on the Genesis Science Network. So I'll let you know where all that goes. But anyway, thank you very much for coming on, Jonathan. I appreciate that.
Fantastic. Well, thanks for having me. I enjoyed it.
Right on. Okay. And when I go off, stay online for a minute, stay in the studio, and it'll upload your video to the cloud. So anyway, okay. Love you in shirt. Oh, thank you. I like it as well. It doesn't make me look like the Hulk about to explode out of my shirt. So anyway, thanks everyone for joining us in the chats. We appreciate that. And hopefully you will join us for the next time. Make sure you catch us on social media to find out when the next live stream will be. I'll now edit this down into multiple shows. I'm going to take a wild stab at probably 4 shows we're going to get out of this for air. So by all means, please send in your questions, because I will use those questions in the mailbag segments of those shows as well. So anyway, all right. God bless everyone. Have a good day.